Hey kids, time for some quiz review. So remember I said I'm going to go through a bunch of problems from the second part of this unit up to the quiz. The improper integrals, right, we've kind of already covered, and in the quiz review homework handout there is some improper integral practice. So I'm going to start with Numeric Series, a warm-up on Numeric Series, because that will be on the quiz. And then I'll go over some of the building a power series, manipulate a power series, geometric series, that kind of thing. All right, so firstly, these are all numeric. Can you tell? There's no x's, right? It's just n's. So which of the following series converges to a number? If a series converges to a number, that you can see, it just doesn't say converge. It says converge to a number. That means you're looking for a geometric pattern, because there's only one series I can find the sum of without doing an improper integral, and that is a geometric series. So look for geometric. So I kind of sort of see geometric here and here. Do you? I'm going to rewrite this as 1 over 2 to the n. And hopefully that then makes you realize that you have your common ratio of r and that your a value is 1. Is 1. So given that my common ratio is a half and the absolute value of a half is less than 1, then this infinite geometric series will converge, and further I can find the sum, which is a over 1 minus r. So please make note of where you start, because a is the first term. So my first term, when I put a 0 into here, is 1, and then 1 minus my r, which is a half, which is 1 divided by a half, which is 2. So this one does converge to C, converge to 2. But you have to check the rest. So how about this one? Does this one look geometric? I hope you think it does. That negative 8 doesn't have an n with it, so I'm going to keep that to the outside. Right, does that look right? Negative 8 times negative 1 over 3 to the n, where you can see again your r, your common ratio, is negative 1/3. Make note of where you start, because as long as the absolute value of r is less than 1, for this geometric series, then the infinite sum is a, the first term, over 1 minus r. 1 minus negative 1/3 is 1 plus 1/3, but a is what? It's not just negative 8, it's the first term. Negative 8 times negative 1/3 to the first. Negative 1/3, right, you're going to put a 1 in here. So that's negative 1/3 times negative 8, which is positive 8/3. So you have positive 8/3 divided by 1 plus 3/3, which is 4/3, which is 8/3 multiplied times 3/4, which is also 2. So B is a series that converges to 2 as well. A does not look geometric, right? So I'm thinking I can't say that it converges to 2. And remember, if it's not geometric, one of the first things you could think of when it's converging and diverging is the nth term test. So plug in 1, 2 times 1 over 3 plus 2 is 5. Plug in 2, 4 over 8. These terms are not going to 0, so this series diverges by the nth term test for divergence. So B and C are the series that converge to 2. So number 2 and 3 should go kind of quickly. I hope you can see, notice I don't have a number. Does the series converge? I don't say, does it converge to 2? I just say, does it converge? And 1 over n is not geometric, but that is a series you should recognize. 1 over n is a p series. Where p is equal to 1, that's the harmonic series, diverges, right? Does not fall fast enough to its horizontal asymptote. But what about this one? -1 to the n plus 1. This is just your alternator. So this series is, right, when you put a 1 in here, you're going to get an even. So you're going to get 1 over 1 plus, minus 1 over 2 plus 1 over 3, right? When n is equal to 3, 3 plus 1 is 4, you're going to get an even, so on and so forth. This is the alternating harmonic series. And remember from pre-cal, the alternating series test, and I talk about this in my interval of convergence video, the alternating series test for numeric series, as long as the individual terms do go to 0 and you alternate signs, converge by the alternating series test, right? It's the only time when the nth, notice here, the signs didn't alternate. The terms didn't go to 0 anyway. But notice here, the terms do go to 0. 1 over 1 plus 1/2 plus 1/3. The terms do go to 0, but the signs do not alternate. So by the p-series is only talking about positive terms, so you can't use the p-series test on an alternating series. On an alternating series, you need to use the alternating series test, which the alternating series, as long as the terms go to 0 and your signs alternate, you will converge. Okay? All right, so there's a review of numeric series. Continuing the warm-up, and this handout is quiz review, complete with improper integrals practice. All right, so write the first 3 non-zero terms and the general term, right? The general term is another way of saying the nth term of the power series for All right, here's what I want you to think when you see this. When somebody asks you to write a power series, you would prefer not to have to use Taylor, where you have to find the derivatives, evaluate the derivative at the center, and divide by the appropriate factorials. You would prefer not to do that. You would prefer to see a geometric, where you can just do AR to the 0, AR to the 1, AR to the second, blah, 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 or a famous Maclaurin, E sine or cosine, or a manipulation of one of those. So look at your function and zero in. Do you see something famous? E to the x is famous. So this is not multiple choice. Focus on the famous part. Without Taylor's formula, you should have memorized e to the x. It's one of the most famous series, and it's very easy to recognize. It is just x to the n over n factorial. There is the nth term, or the general term. X to the n over n factorial is the polynomial expansion of e to the x. Now, I want you to also realize that what you have up here is an equal sign. You have an equal sign here as well. I want you to take notice that g of x is a combination of things happening to e to the x. What's the first thing that happens to e to the x up here? Subtracts 1, right? So look at my line here. I have an equal sign. Aren't I allowed to subtract 1 from both sides? That's legal, isn't it? So I took e to the x and I subtracted 1. I took this infinite polynomial and I subtracted 1. Notice when remember something you do in algebra, right? 2x plus 7 is equal to 14. 14, let's say 14 plus y. And I wanted you to get x by itself. You would subtract 7 from both sides, wouldn't you? You wouldn't subtract 7 from the y because it's not matching. You wouldn't subtract 7 from the x. You would subtract 7 from the matching part, the constants. Right? So e to the x minus 1 is just e to the x minus 1. This is an infinite polynomial. Where are you going to subtract the minus 1 from? The matching term. Isn't that kind of cool? So e to the x minus 1 is this whole polynomial minus 1, which means the 1's go away. You have just taken care of the numerator. That's not what g of x is equal to, though. What is the next thing that happens to e to the x minus 1? It gets multiplied by 1 over x. So multiply both sides of your equation by 1 over x. Now, it asked me for the first 3 terms. I went ahead and wrote 4, and I'll tell you why I did that in a minute. So hopefully you can see that 1 over x times e to the x minus 1 is e to the x minus 1 over x, right? Now just distribute. One over x times x is 1. Each time the denominator is going to get an x, isn't it? When I distribute, this is going to get an x, an x, an x, an x, which is going to cancel with one of the x's up here. So do you see what ended up happening to my, right? I got an x over x here, x squared. This ended up just being an x over 2. Well, sure, you can call it 2 factorial if you still want. And really, there's a 1 factorial still here, right? So do you see where I got the general or the nth term? Notice now with this manipulation, my power doesn't match my factorial. It's 1 less. So in my nth term, I just wrote x to the 1 less power than the factorial. Right? So many kids look at a problem like this and they think, oh crap, I need to use Taylor's formula. So I need to do the first derivative, which is a quotient. And the second derivative, oh my gosh, and evaluate it. Now the center is 0. I can see that the center is 0. But still, what an awful lot of work when you really just had to recognize e to the x was famous, subtract 1 from both sides, multiplies both sides by 1 over x. Done and done, honey. All right. The next thing I want you to do, if you haven't already, is either pull up on your computer or print out the quiz practice classwork. For practice. So the first thing it asks you is, given the function cube root of 1 plus x, which I'm going to write like this. Write out the first 4 non-zero terms. They don't ask me for the nth term. Write out the first 4 non-zero terms of the Maclaurin, which means the center is 0. This is neither geometric nor famous. Therefore, I have to go to Taylor's formula. Remember, Taylor is the same as Maclaurin when the center is 0. So Taylor's formula says evaluate the function at the center divided by 0 factorial x to the 0. They want the first 4, right? Dot, 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 dot. So I need to take f and find its derivatives. Fortunately, I took the first half of of calculus, so I know how to do this. Bring the 1/3 down, 1 plus x to the negative 2/3 times the derivative of the inside, which is just 1. F double prime of x is negative 2/9. 1 plus x to the negative 5/3 times 1. And that's going to give me 1, 2, 3. They asked me for 4, so I need one more derivative. Why am I doing it over there? Positive 10 over 27. 1 plus x to the negative 8/3 times the derivative over the inside, which is just 1. Evaluate all of those derivatives at the center. And divide by the appropriate factorial and match your powers. So plug in 0 here, and I get 1. 1 x to the 0 divided by 0 factorial. Plug in 0 to the first derivative. 1 to the, I don't care, power is 1 times 1/3. So 1/3 x to the first over 1 factorial. Plug in 0 to the second derivative. Negative 2/9 times 1 to the whatever power is still 1. So that's negative 2 over 9 x squared over 2 factorial. Plug in 0 to the fourth derivative. 10 over 27 x cubed over 3 factorial. So there is the first 4 terms of the Taylor approximation for f of x. They did not ask me for the nth term, so I'm not going to write it, and I'm not going to bother to reduce anything. I'm going to leave it just like that. If it was multiple choice, it would look, they would have combined stuff, but it's not multiple choice. I'm done. Now, they want me to approximate. They want me to use my Taylor to approximate a number close to 0, the center. My Taylor polynomial at 0.5. So this is, you would have a calculator and you would plug in 0.5 here. And I did with my calculator, I got 1.14, blah, blah, blah. $146 I'll put, because I have to put three places past the decimal, blah, 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 blah. They asked me to compare that with the actual value of f of 0.5, excuse me. F of 0.5 using my calculator, because I have the function after all, so I just plugged in 0.5, added 1, and took the cube root. And I got 1.147, blah, 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 blah. So you can see that they're darn close, right? If I took the absolute value of that, it's 0.001, blah, blah, blah. Right? Very small error in using 4 terms of the polynomial to approximate that function. Pretty good. You will have your calculator on the quiz. All right, that was a Maclaurin. Now they want me to do the same thing with the same function, give me a Taylor, which is not centered at 0. So I have the same derivatives. Now I erased them, but I assume that you did not. So I have that first part is exactly the same, right? So the Taylor polynomial is going to look like f of 0. No. F of what? -2, right? So you use the same function and the same derivatives. Same function, same derivatives, but you don't plug in 0. You plug in -2. Come on. -2, -2, -2, -2. When I plugged in -2, I got -2, the cube root of -1, which is just -1. -1 raised to any power just keeps changing its signs. So I plugged -2 into here, and again, I got the cube root of -1, which is -1. Technically times x minus -2 to the 0 over 0 factorial. Then I plugged in -2 to the first derivative, and I got positive 1/3 x minus -2 to the first over 1 factorial. Then I plugged -2 into the second derivative, and I got positive 1/9 x plus 2 squared, I got 2/9 over 2 factorial, and then plus 10 over 27 x plus 2 cubed over 3 factorial. Did I have 2/9 up there at that last one? Sorry, I think I also forgot the 2/9. I think up here I wrote, and now I've erased it, so double check, right? This derivative at 0, when I was doing the Maclaurin, the derivative is 2 over 9, and the 2's cancel out with the 2 factorial. I don't remember now if I wrote it that correctly or not. I apologize. Right? You can see that these 2's will cancel out here. All right. Then they asked me to approximate with Taylor. That's the same thing I did before. So I'm going to plug into, and I'm going to use my calculator, and I'm going to replace, I'm going to take that Taylor polynomial, and I'm not going to approximate it at 0.5. I'm going to approximate it at a number close to the center. So they asked me about -2.2. Which is approximately f of 2.2. Again, I just used my calculator. I got -1.063. Right? I didn't bother to compare it this time. But as long as the approximator is close to your center, then your approximate value is going to be very, very close to the function value around -2, right? Very, as long as I just shifted it so that I could use the approximator near -2. Manipulate a Maclaurin. Now on the quiz, I won't say you're going to manipulate a power series. You just need to recognize you spent an awful lot of time making this Maclaurin, and this f of x is almost the same. The only difference is there's an x squared. So since you already did this, you already got this one. So again, I'm going to write it down because again, I'm not confident that I wrote it down correctly the first time. This polynomial, the first four terms of it, was 1 plus 1/3 x minus 2/9 x squared over 2 factorial plus 10 over 27 x cubed over 3 factorial. Recognize, if as long as you recognize that this is the cube root of 1 plus x squared, which is the same as this f. I probably should have named this a different value. This is just f of input x squared, right? Just input x squared into there. So all you have to do is go to each one of your x's and compose an x squared in there. One has no x, plus 1/3 x squared minus 2/9 x squared squared over 2 factorial plus 10 over 27 x squared cubed over 3 factorial. And I'm going to just leave that like it is. Okay. So once I make you build a function, expect to be asked to manipulate it somehow, whether it's a given, like in the warm-up where it was e to the x and you were manipulating it, and that was just, you didn't have to build that at all. You're supposed to memorize e to the x. And then here where I asked you to build one from scratch, I'm not going to ask you to, right after that, build a whole nother one, right? That is so similar. Use what you did before. Notice when I shift, I did have to rebuild when I shifted my center. That's not a manipulation, that's a shift. Oh, shift, right? That's not a manipulation, but I could use the same derivatives. I just had to make sure to shift every x and evaluate the derivatives at the new center. All right, here's another one. So, AP style. Suppose I have a function that's differentiable at least 4 times, and it is known then, blah, 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 blah. Construct the first 4 non-zero terms of the Taylor around a center. So they could have said Maclaurin and not named the center in this case. So notice here, you can't use Taylor's formula. You can't find derivatives because no one told you what the function was. But you do need the formula to know that f of x is exactly an infinite polynomial where it is the function evaluated at the center plus the first derivative times x to the first over 1 factorial plus 5 x to the second over 2 factorial plus 0 times x cubed over 3 factorial plus what? 7x to the 4th over 4 factorial. Plus dot, 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 because I wrote in equals. If you could just write approximate and stop, you wouldn't have to write dot, dot, dot. But this, the way this problem is presented, it could be either way. Now, suppose that g of x is equal to that same f of x squared. Use the information that you just did. This is very AP-like, so use what you just had, which was 3 minus 2x plus 5 over 2 factorial x squared plus that 0 term, 7 x to the 4th over 4 factorial, and compose x squared into it. If you need to match multiple choice, clean that up. If you don't, don't. Done and done. Done. Now, look at this. This is interesting. Suppose that the derivative of f, which I'm going to call h. So f, right? We already know what f is. F is 3 plus 2x plus 5 over 2x squared plus 7 over 4 factorial x to the 4th plus dot, dot, dot. So suppose I have a function h that is this derivative, that f of x is its derivative. And further, I gave you an initial condition. I want the first 4 non-zero terms of the Taylor series of h around 0. They said Taylor, so they have to say 0. Interesting, right? So I know that h prime of x is equal to 3 but I want h. If I have h prime, how do I get h? Yep, anti-differentiate, baby. Anti-differentiate term by term. So how do you anti-differentiate? 3x over 1. Oops, sorry, this was a minus, wasn't it? Minus 2x squared over 2, so the 2's will cancel out, plus 5x cubed over 2 times 3, plus 7x to the 5th over 4 times 5. Whoa, 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 whoa! Who can't you forget here? Who can't you forget? Plus C, baby. Plus C. How do you find C? Hello, my initial condition. Right? Do you remember doing this in, right, unit 5? No, unit 6? 6, h of 0 is 6. So plug in 0. And if I plug in 0 for every x, what do I get? Even all these infinite ones have an x in it. So what do you get? You just get c is equal to h of 0. What was h of 0? 6. You just solved for c. C is a constant. Therefore, h of x, now you're not going to want to write that 6 way over here. Write it first. 6 plus 3x minus x squared plus 5x cubed over 6. You can go ahead and write another term, but you don't have to. They only asked for the first 4. With my constant, I don't actually need that one. OMG. Right? So in our live session, I did an example where we were taking an infinite polynomial and differentiating term by term. This time, I anti-differentiated term by term, but I gave you an initial condition. So that you could solve for C. But if you didn't remember C, you would never have been able to solve for it. Whoa. All right. So again, here, another practice with a famous Maclaurin series. If g of x is equal to e to the 3x, p of s is the Maclaurin. What is the coefficient of just the, so they didn't ask me for the whole thing, they just asked me for the coefficient. So of the x to the third term. So what you have to realize again is that you've got a famous function, e to the x. E to the x is famous. You're supposed to know that e to the x is 1 plus x to the first over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial. They asked me, though, for e to the 3x. So for every x in my original, I have to put a 3x. Nowhere to put an x. Instead of x, put 3x. Instead of x, put 3x squared. Careful, all of 3x gets squared. Plus over 2 factorial. Plus 3x cubed. Careful, all of 3x gets cubed over 3 factorial. All they wanted was the coefficient. So look at this, 27 x cubed over 3 factorial. They just want the coefficient, so only give them the coefficient. Right? I don't care whether you write 27 over 3 factorial, or if you write 27 over 6, or if you write, 9 over 2. All of those are correct answers. If it's multiple choice, you would have to match one of those answers. All right, so again, on the homework, the homework sheet that goes along with this, and again, the answers are already there, make sure that you pay attention to the language. This is the improper integral practice. If you're evaluating an improper integral, that means you are integrating. You are actually going to integrate, and you are going to get a number if you converge, and you're going to get an infinity if you diverge. Okay. Number 2 is still improper, but you will not integrate. Do you see the directions? No integration. Determine whether. That means you are using the DCT or the LCT. And remember, I told you that on the quiz, I will tell you which one. You don't have to decide. I want to test both. So I will say, do the direct comparison or do the limit comparison. But don't, for God's sakes, integrate. You will have a question on a numeric series, whether it converges or diverges, right? So numeric series, you need to look for geometric series, P series, alternating series, or if it diverges by the nth term, things like that. If it is geometric, then find the sum. If it is a P-series alternating, and of course if it diverges and the terms don't go to 0, then it diverges. You don't have to find, but you cannot find a sum of an infinite P-series or an infinite alternate series without doing an improper integral. And I don't want you to do an improper integral. Okay. If it's geometric, you have a formula. A over 1 minus R. All right. So again, that key is on the in files. Oh, I did want to make one note too about the DCT and LCT for the quiz. Please make sure that when you are doing the DCT, right, for these problems, again, you're going to integrate. So there's going to be rubric points for integrating. There's no integration here. You're doing the DCT or the LCT. Now, I've allowed you to choose here, but you can look at my key to see which one I chose. Remember, for the DCT and the LCT, make sure the first thing you tell me is who you're comparing it to. The second thing you tell me is what do you know about your choice, right? These are your kissing cousins, right? I'm going to compare to 1 over x squared. 1 over x squared is a P series. P is equal to 2. Therefore, this series diverges. Converges. 3, if you're doing the DCT, your next thing is you talk about the position. If your known function converges, then your function has to lie under it. If your known function diverges, your function has to lie on top of it. Or if you're doing the LCT, then you're doing limit work. And then 4, your conclusion. Okay? You're not really doing a whole lot of math in there, so make sure you talk about who you chose, what you know about your choice. The direct comparison test requires that you compare the positions of the functions, the known and the unknown, to one another. The LCT makes you do a limit of the ratio of the known and behavior of the known function to the unknown one. All right? All righty. I will see you tomorrow or your teacher on Friday. Take care.